And let's see what we got. Chapter 11. We just finished chapter 10, clearly. And, we had some conversations about next semester how I might spend 2 weeks on one thing instead of 2 weeks on C's, do 2 weeks on pointers, and on and on and on. But we got the
Oh, shoot.
last program done, and most of them looked pretty darn good. Some of you had trouble with the dollar signs, question marks, those type of things, but overall, they were pretty good. All right, chapter 11. This is number two as far as big things that you're going to be using from this course in the next course when you go to 161. And what I mean by that is this combined with stuff that you were doing with memory addresses and pointers is going to be a big part of the whole semester next semester. You're going to talk about actually data types, and you're going to look at the data types and say, well, what if I worked with them with arrays? What if I worked with them as this new thing, which is a combination of a structure and a pointer, and it's called a linked list. But we're not going to worry about that right now. So an abstract data type, bottom line is you're creating your own. You are creating your own. Okay. And, we've done simple ones like int. That's a data type, and it has a range of values. Okay? Doesn't have any set operations, procedures to go with it, but that's created by somebody. Well, next semester, you're going to get into creating a lot of them. Okay. And they're going to have their own range of data, and they're going to have their own operations or functions to go with them. A little bit kind of like a class in a sense. But anyhow, you went through the videos. Hopefully, you saw what structs are, and you have this layout for struct. You use the reserved word struct, and then you have a tag. Okay. And the tags usually will start with an uppercase. That was declaring what you want to call this data type. Hey, I got a data type employee.
Hey, Tanner will be here in a few minutes. They just don't know where their headphones are.
Okay, sounds good. Thank you. Okay, so we're going to say, I want to create something. It's called employee. Now, instead of it being called int, I'm naming my data type employee. Now, what's unique about this? Well, this is kind of like the old school Rolodex, where you would have an employee, and on that Rolodex card, some of you don't even have any idea what I'm talking about. You had the name, you had an age, and you had an address. Okay. We have several different data types inside of our new data type. We have strings and ints and more strings. Oh, hopefully when you create these, you notice there's something that we haven't seen before. That's the semicolon after the right set notation, aka brace, also known as a squiggly bracket. So we're going to be able to create our own data type. Questions? You saw a bunch of this, what was going on. And again, we have one, and we're going to declare something of type employee. So instead of int num, we're going to have our data type employee, and then emp. I don't know what you want to call it, but the same kind of setup. Semicolon, semicolon. It's a data type. Okay, coming over to this next page. The fields, the members, you're going to hear them called different things. I am in the habit of calling them fields, maybe not from this course, from another, but you're going to use something and it has a specific name. It's called the dot operator. And if you look down here, you'll see circle one dot, and this would be one of its members, radius, and it's going to hold a value, probably a double. So over here, I may say something along the lines of emp dot one of its members, age equals 50. I'm working with emp. It's of type employee. I'm working with one of its members. Once I declare it, I can add. So this is where it's different than old school arrays. Arrays were homogeneous. They were all the same data type. These inside have different data types. Can we compare them? What does this compare? If circle one equals circle two, they are both of the structure type circle. This is comparing what? That's a pretty bad face. Addresses, right?
Addresses or
Yeah, if I want to compare and
something
see,
already defined.
right, I may have to get in and actually do this deep comparing, just like we did with arrays. We want to go through and compare each one. Okay, you saw a bunch of examples from the video. These are examples. This is kind of different, sort of implicit. If I create a new city of type city info, I can fill in the first member, first and second member, first, second, third member, all kind of what we used to call implicitly, assigning it when I'm declaring it. And you start thinking about the world of classes. Ah, this is yeah, this is in my class. What was that when I instantiated an object, I called a what? C word. It's almost kind of like we dealt with constructors, right? We had one, two, or three, and some different things going on. So just trying to fill in some pieces. The next thing, can I have an array of these structs? Yeah, I declare it. Here's my data type. Here's my variable name. Here's the size of it. City sub-zero dot name, city sub-zero dot state. Good. Between the code listings and the video, hopefully all that came out pretty good. We got this guy. Now that I know another data type, what if I pass it in as an argument to the function? What if I return it? Well, you typed in two code listings, and the first one, this is another one. How am I doing? And hopefully, till we're all said and done, you'll get here's the prototype. Okay, I'm passing in something of type inventory item. Why am I passing this in with the ampersand?
So reference.
The reference, so I can do what to it? Yeah, it's passed as a reference. So I can do what to it?
Add to it.
Yeah, I can change it. I can make changes. So that's why that one's passed by reference. This one's passed by value. Okay, we're starting to do more and more with our prototypes, and we want to make sure we get this layout correct. Let's see, I call get info. I'm sending something in, and it's going to get filled and changed. When I call show item, I'm going to send it in, and if it gets changed, I don't care. It's coming back with the original values. This is going in as an address, which will help. And taking a look at it, here's the one where the address is coming in. I'm now calling it P so I can work with it and make changes. Here's the one where just the value is coming in so I can display it. So code listing 11.6 and 11.7 are great when I get ready to start working with my functions and how I want to work with a struct. Here's a struct that's defined. Here's a prototype. I am returning something of type circle. I'm returning something of type circle and storing it in C. Line 24 has that laid out. Last thing is, what does it look like in the heading? I'm my return type, my function name, nothing is coming in. I create a local variable called temp circle, and I return that temp circle. Yes, yes, and still good?
All
Yeah.
good here.
All right. Now I just need to find where my notes are right now. 11.6, 11.7, 11, and 11.11. Now we're going to cover 11.11 briefly, and you're not going to hear a whole lot more about it because this is something called an enumerated data type. And we talked about this briefly, excuse me, in 121, but we really never use it. In the world of computer science, there is an enumerated data type, and it's almost like I created it and it's called Boolean. And Boolean works with two words. One is the word false. Notice it's not in double quotes. True is not in double quotes. When I create a set with values, they get numbers. First one is 0, second one is 1, and so on and so on. But what an enumerated data type is, it allows us to use words to represent a number. When I say false, you say 0. When I say true, you say 1. When I say what comes after false, you tell me true.
True.
Yeah. What comes after true?
False.
False. Right. Everything has a successor and a predecessor. It has something that comes before it. What's before false? True. What's after false? A successor. It's also true. Okay. We make up the words we want. And here's the classic example. An enumerated data type. Monday, Tuesday, Wednesday, Thursday. And again, this is probably something we're never going to use. We're never going to make up a data type. So just like we made up a data type with structs, we're making up a data type called day. And anything of type day, I declare work, is going to get one of these four values. Okay, up here I declared something called boo. Boo, I can pick a variable name and it's going to get the value of false or true. Now, see out false, it's not going to do anything with false. It's going to give me its what we call ordinal value. Has an ordinal value of 0. Wednesday has an ordinal value 0, 1, 2. I declare work of this data type day, give it the value Tuesday. So it's a second data type that we're learning in chapter 11 that is a big precursor to what you're going to do in 162 with creating data types. Okay, staying with the enumerated data type, declare work, doo int x equals whatever Tuesday was. See out x, I can print out the number. Continue with enumerated data types. I can actually use my relational operators. Talking about structures. Yeah. It's all on the video, and we're only like 10 minutes in, so it'll be an easy watch to catch up. But we're running through chapter 11 in this new data type called struct and this new data type called enum. And again, we have enum, excuse me, and from the code listings, you did some work with enums. And just, we'll get back here. Just to take a look at a quick example, there it is, what I was just talking about. Monday, Tuesday, Wednesday, Thursday, Friday. Oh, look at this. I do a loop from Monday to less than or equal to Friday. Basically, that's from what numbers?
0 to 5.
Yeah, 0 to less than or equal to 4.
4.
So it's going to run through that. So we can use words instead of numbers. And, it's saying you can do it. In 40 years, I've never had students write a program to do it. Okay. Here I'm using it as a subscript value. Enter the day so we enter work day, we enter Tuesday, what would go there would be 1. We're using these and this variable instead of numbers.
Mhm.
Yeah, Tanner loves them. Okay. Made the code easier to read. I'm okay with that. I'm okay with that. So there's a bunch of good examples, and there's, going to be a question or two on the test. So you need to know them. We have to cover them, and we cover them. And maybe something in your junior or senior year, they'll go, hey, by the way, we need you to do enumerated data types kind of deal. All right, questions. Questions on chapter 11. Again, I'm only doing an overview looking for questions. Watch the video. Now this overview. Now get your hands on it and get dirty. Let's get dirty. Okay. I'm looking at page 662, number 11. Number 11. And I'm giving you a bunch of time, excuse me, to work on this. Way to program it simulates a software machine. The program should use a structure that stores the following data. So you're going to have a struct. I don't know what you want to call your struct. What do you want to call it? Say drink. And then you have string name, double cost, int, number of drinks. Okay? So that would be your struct. Putting lots of stuff together. I want you to read from a data file 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 things and store it in an array of structure. So, in my mind, what am I doing? I am creating the struct. I'm going to fill array of structs. I'm going to display to make sure it all works. Display all. Step by step. Do this, compile it, make sure it runs. Do this, compile it, make sure it runs. Do this, compile it, make sure it runs. Work through everything. Okay, then what's the user going to be able to do? The user's going to, somehow you have to say, which drink would you like? And I would prefer the user to enter a 1, 2, 3, 4, 5, not the words. It's much easier doing this. For your baseball programs, I had to type in New York Yankees for just about everybody. The numbers would have been easier. And how many times did the New York Yankees win the World Series? 27. And I'm not a Yankees fan. Not since earlier, the code listings don't touch on enums at all. Oh, didn't I have those included? My apologies. I thought I had a couple of them in there.
You posted one. It
I'm
was
sorry?
11, 12. You posted one. It was 11, 12,
Oh, okay.
I think.
Okay. All right. So once then everything works, you're going to display this. You're going to ask the user what would they like to buy. They're going to type in 1, and you're going to ask them how much money they're inserting in the machine. And then you're going to tell them what their change is. And then you're going to update your arrays so that when you display this again, there'll be 1 less in the machine.
So you're displaying a menu with the number
I would
coordinating
I
with the flavor.
yes, I would. It's kind of like a menu, yes, but I would display this and ask, would you like to buy a soda? If so, which number? Else, enter -1 to quit kind of deal. And then depending on what they pick, you will call and take care of that. Okay? Questions? Should you use functions? Yes, because during class we talked about returning a function, returning a struct. We talked about how we did a reference variable when we sent it in to fill it, etc., etc. Questions? I think this is a good exercise. Put all this together. All right.